When you run code, you're basically asking a computer to follow a set of instructions you've written. The computer doesn't understand your intentions or ideas. It only understands very small, precise steps. So the first thing that happens is translation. Most code is written in a programming language designed for humans, not machines. Languages like Python, JavaScript, or C++ use words, symbols, and structure that make sense to people. But computers only understand machine language, which is made of simple binary instructions, ones and zeros. So before anything actually runs, your code has to be converted into something the computer can understand. How this conversion happens depends on the language. Some languages are compiled. That means the entire program is translated into machine instructions before it runs. Other languages are interpreted. In that case, the code is read and translated step by step while the program is running. Either way, the end result is the same. The computer gets a stream of very basic instructions. Once the code is translated, the operating system gets involved. The operating system is like a manager. It decides whether your program is allowed to run, how much memory it can use, and how much attention it gets from the processor. When you double-click an app or run a command, the operating system creates a new process for that program. A process is basically a live instance of your code. Now the processor, or CPU, starts doing the real work. The CPU doesn't run your program all at once. It works in tiny steps. It fetches one instruction, understands what that instruction means, and then executes it. This cycle repeats billions of times per second. Even a simple program can result in millions of these tiny steps happening very quickly. Oh yeah, while this is happening, memory plays a big role. Your program needs space to store data it's working with. That space comes from RAM. When your program starts, the operating system loads parts of it into RAM. The CPU then reads instructions and data from RAM, because it's much faster than reading from storage like a hard drive or SSD. As your code runs, it constantly moves data around. Some data is temporary, like numbers being calculated or text being processed. Other data might be more permanent, like files being saved. Temporary data usually lives in memory. Permanent data is written back to storage. This back and forth happens automatically, without you noticing. By the way, your program is usually not running alone. Modern computers run many programs at the same time. Your music player, browser, system services, and background apps are all active. The operating system rapidly switches the CPU's attention between them. A simple way to think about it is like following a recipe. You write the recipe in a language people understand. Before cooking, it's translated into exact steps. The kitchen manager makes sure you have space and tools. Then each step is followed one by one. If a step is missing or wrong, the dish fails. So when you run code, you're not just starting a program. You're triggering a chain of translations, checks, and executions involving the operating system, memory, and processor.